Actually,
Yeah, that's what I said. I wasn't kidding.
you're being sarcastic.
I mean, you weren't like on time to school, but you were on perfect time for the lesson. Yeah, yeah, that's what I said.
Yeah.
That is okay. Not really sure what's happening this morning.
What?
We're gonna finish 7-4. Okay, before we get into it, we're gonna start on this problem, but I want to remind you that for your quiz tomorrow, these area problems are fair game. So make sure that you know how to do those area problems. I think everything else is in 7-3. You'll have these RREFs. You will have Kramer's rule. You'll have to do inverse method. You can either do it by hand or on the calculator because you get a calculator for this whole quiz. While these might be fun, they are not that helpful. So make sure that you know how to use your graphing calculator, how to enter matrices in, multiply them, do determinants, do inverses, do RREF. That's going to be really helpful. It should be a very easy quiz, but if you don't know how to use your calculator, it's going to get really tough. Avery.
For the Jordan one, are we literally just doing RREF? Like, you
Yep.
have to do all the complicated stuff.
I think I told you that you can do whatever you want, but if I were you and it doesn't make me do REF and substitute, I would do RREF, so I just get the answer. Notice how on all of these problems, I've shown you the matrix. I've shown you this is the starting matrix, and then I tell you what I did in the calculator, and then I did my answer. Same thing with inverse. If you do inverse in the calculator, show me your AX equals B matrix, then write X equals A to the negative 1B, and then give me your answer. If you don't give me enough work, I will mark off points. Okay.
Oh, for the RREF,
Yeah.
would be both of them?
No. I think I'd give you the option, and I know which option I would take. Okay, that being said, so that's all the stuff on the quiz. Anybody quiz questions? Okay, what we're gonna do now is we've got to finish 7-4. So why don't you go ahead and do this problem for me really quick? We're gonna graph letter 3A, I guess. You already know how to graph. We've got all the rules over here. I'll leave that up on the board for a second until I start doing it. See if you can graph on your own. My goal is in a minute to grade your homework so you can get it back. And so that you can use it to study. I'll try and speed grade it at some point today. Take a second, you're doing 3A. I've got all my work out. I'll graph all those things in a minute. This one, because I've got 2 vertical asymptotes, it's got 3 pieces to this graph. I haven't done a ton like this, but you should know enough to be able to mimic it in some capacity. This part, once I graph what needs to be graphed, all the things that I know, what else do I need to put on this graph? Good, I got little C curves up in the top left and the top right. Nice little review of graphing rational functions. Nope, graphing is not on this. Nor is what we're about to do. We're gonna go do the letter B of number 2, which is partial fraction decomposition, I believe. And so that is not on the quiz, but I promise it will be on the test. And in case I haven't verbalized, the test is gonna be next Wednesday. The calendar is not up to date yet because I have it still on for Friday, but we slowed down a little bit. We're quizzing Friday. We'll take our test on Wednesday. I don't see you on Tuesday next week, so we'll review Monday. You have a day off, and then we'll take our test on Wednesday. Okay. All right, if you guys are ready, let's go up and let's do one more fraction partial decomposition. We've got all of our steps. This one's going to be a little bit funky because I've got 3 pieces instead of just 2, but I want to review it. You have all your steps up here on the board that you can always reference back to. Okay, you guys ready to do one more like this? Okay, so what was the first rule that we said? What do we want to do first? Factor the denominator, right? So I'm going to take the numerator stays the same. You don't have to break that apart. It's fine as is. We're going to factor the denominator. What can I do first with that denominator? Take out an x. Good. So I'm going to take that x out, and then I will factor that like a quadratic, like we're used to.
You don't take anything out of the numerator?
You don't have to worry about the numerator. We can leave the numerator as is. Leave it alone. Only factor the denominator. And so I get on the denominator x minus 2, x plus 1. You guys all okay with that? My next step is to separate my fractions. So in this case, I'm going to have 3 pieces. So one of my fractions is going to be over x plus my other fraction, which is over x minus 2, plus my other fraction, which is over x plus 1. This is the part that's a little uncomfy, but I want you to kind of sit with the uncomfortableness of it. I want you to label the tops a sub 1, a sub 2, a sub 3.
You say this was no inclusion?
No. Not gonna be on the quiz. All right, so the whole reason we use that is we're going to change those to x, y's, and z's in a moment, but I already have x's in my equation, so I don't want to confuse myself. These x's mean different things. So once I separate my fractions out, my third step is what? Clear my denominator. So what am I going to multiply by everything in this?
X.
Good. X minus 2, x plus 1. Okay. When I multiply by that first fraction, the whole denominator gets canceled out, and I'm just left with 12x squared minus 3x minus 12. When I multiply this to my next piece, only the x goes away, So I have a sub 1 times x minus 2 and x plus 1. I have a quadratic. It's going to get a little bit messier than we're used to it being, but it's going to work out okay. Okay, next I'm going to multiply by my second fraction. So the x minus 2 goes away. And this time I'll multiply a sub 1 times x and x plus 1. And then last, I'll multiply that last fraction. Awesome. If you want to drag your desk in the hallway, or if you want to sit here and stuff with me. Any of the empty desks are fair game. And then I will multiply all of that by this last fraction, and the x minus or x plus 1 cancels. And so I'm left with just x and x minus 2. All right, the next step says combine like terms. That just means we need to clean this up, and we want to get all your x squares at the beginning, x's at the end, and then or in the middle, and then constants at the end. So why don't you go ahead? Why don't we FOIL things out? Why don't we distribute? Why don't we do all that fun stuff? And then I hopefully will be ready to explain how we were going to manipulate and move things around. Okay. Calculator. Okay. Okay. Hopefully you guys are a step ahead of me, but I'll catch up. As much as it kind of like feels weird, I want you to distribute that a sub 1 to everything, a sub 2 to everything, a sub 3 to everything. And I think it's easiest if you put that a sub number at the end. So like that first term, when I do a sub 1 times x squared, I'm gonna go x squared and then a sub 1. I'm gonna go minus x, a sub 1, minus 2, a sub 1. Plus x squared, a sub 2, plus x, a sub 2, plus a sub 3, plus x squared, a sub 3, minus 2x, a sub 3. I know there's a lot of subscripts and superscripts. We're just trying to keep everything straight. As straight as you can. Now on the last problem, because there are only 2, I like rewrote it and then went to that last step. But when I was working with Alpha yesterday, we like identified everything and we just made our own 3 equations from right there. Okay. So right now you'll notice on the left-hand side, I've got an x squared term. Ooh, that highlighted really good. Got an x squared term. I have an x term and I have a constant. Okay. I'm going to make 3 equations with those. So I'm going to have an x squared term. So 12x equals everything that's an x squared on the right side. I'm going to have negative 3x equals everything on the right side. And I'm going to have negative 12 equal the constants on the right side. You guys all okay with what I'm doing right now? Well, bring your a's with you. So I'm going to go x squared a sub 1 plus x squared a sub 2 plus x squared a sub 3. Now, before we go to the next one, do you notice something that's in all of those terms in that equation? Even more specifically, an x squared. If there's an x squared in all of those, you can get rid of that. And you can just write this as a sub 1 plus a sub 2 plus a sub 3. If you want to copy it directly over, you could say 12 equals that on the left-hand side. Or if you want to make it look, actually, no, we'll keep it like that. We'll go 12 equals. I'll rearrange it in a second. Now that we've gotten rid of the x, we can make those a sub 1s, a sub 2s, a sub 3s variables that we're used to seeing. So I can make that x plus y plus z. Those feel a little bit more comfortable to us, right?
Yeah.
Now, this is where I would rearrange it. I want the equals on the right side. We're used to seeing the equals over here. So I can switch 12 equals. I can just flip it. Symmetric property of equality, I'm allowed to do that. This looks more like a familiar equation, correct? So we're going to do that with the next two as well. So we're going to take them from the equation, from the original equation. We're going to make them look more normal. So, okay, now we're ready to identify all my x's. Let's see. I've got negative 3x. I've got minus x a sub 1. I've got plus x a sub 2. And I've got minus 2x a sub 3. I'm taking everything with just an x and I'm putting it in the second equation. Do you notice anything that's in all of those terms in that second equation? X. If they all have an x, can we just get rid of that x? Yep, cancel it out. So again, if I were to copy this, I would get negative 3 because I got rid of the x. I'd write negative a sub 1 plus a sub 2 minus 2 a sub 3. On that top equation, I just got rid of all my x squares, everything else stayed. On that second equation, I got rid of all my x's, everything else stayed. And then if I want to go one more step to make this look nice, I'm going to write, instead of a sub 1, I'm going to write x. I'm going to write negative x. Instead of a sub 2, I'll write y. And instead of a sub 3, I'm going to write 2z, negative 2z. And then I'll put that negative 3 on the opposite side. See how we're kind of getting to the place that we're used to seeing. Last one. And if you notice, I don't have a lot left. Now I'm doing constants. I've got negative 12. The only constant, the only thing I haven't touched on that right side is negative 2 a sub 1. I technically, you don't have to write this, but I technically have 0 a sub 2 and I have 0 a sub 3. You guys all okay with that? So then, again, like we wrote before, we're going to take this and we're going to make it into 6. We could do that, or we could leave it as is. If we had it as 6 equals x, that helps us, but like we can't still solve it by hand. We're still going to have to put it in the calculator. I didn't do it this way last class, so I'll do it this way and we'll see if it works still. And so I can write x equals 6. Now do you see that I have 3 equations that look like our systems of equations that we're used to seeing? Okay. You have a lot of different ways you can solve this. You could use inverse method. You could use Cramer's rule. You could use REF. You could use RREF. What do you want to use? What's the easiest thing to use? RREF. So let's write this as an augmented matrix. Let's put it in our calculator. Let's press RREF and then we will solve. So again, I do need to see your augmented matrix. 1, negative 1, 1, 1, 1, 0, 1, negative 2, 0, and then 12, negative 3, 6. We have a 3, 4 matrix. And if you have trouble knowing what size your matrix is, you'll find out really quick when it fits or doesn't fit your box. Double, triple, quadruple check all your numbers. Because nothing is more embarrassing than just like missing a negative or typing a negative that you don't need and then your whole problem's screwed up. Okay. Second matrix. Our REF is in that math menu. Of course, I have an ad. Because they're ahead of me. Make sure you're entering this in on your calculator because I can't help you with this. If you don't know how to enter something in, I'm gonna be like, sucks to suck. I know that's not very nice, but that's how I feel. You need to enter it in. Your calculator might look different than mine. Okay, ready to go? And just like we are expected, we get a nice matrix over here where all my ones are my diagonals and my answers are 6, 5, and 1. Now, this is not the very end. We've got one tiny step before we go to the very end. Is everybody okay with these numbers though? Everyone's okay with 6, 5, and 1? Okay. The very last step I want to do is I want to take this original equation and I want to replace a sub 1, a sub 2, a sub 3. So I'm actually going to kind of use this space over here. And I'm going to rewrite it. I've got 12x squared minus 3x minus 12 over x to the third minus x squared minus 2x. That was my original equation. And that equals something over x plus something over x minus 2 plus something over x plus 1. And we found that those numbers, a sub 1, a sub 2, a sub 3, are 6 and 5 and 1. So I want to see this at the very end of your problem. If I don't see this, this is what we were working towards the whole time. If I don't see this, you will not get full credit.
So are you gonna give us a lot of requirements? Yeah.
You think I'm gonna make you do a lot of these on a test? No, probably one. It's a lot of steps. I don't think any of it's that difficult of math. It's just you have to remember first we do this, then we do this, then we do this. And again, I think the hardest part is using those a sub 1s and then eventually getting it into x's and y's and z's.
Let's put it over 6 over x. Oh, it's the parts that we took apart.
Okay, that is technically the end of 7-4. So 7-4 homework is due on Friday when I see you for your quiz. Remember that what we just did, the graphs, not on your quiz, area, yes, on your quiz. Okay. We are going to go do a couple of 7-5 right now. I hope to do 2 of them and then still give you some time to work on homework. Depending on timing, we'll do the last one after the quiz, and then you will have learned all of chapter 7. Okay. Is what we're about to do right now on your quiz. For sure, no. Okay, great. Good. I just want to make sure we're good. This one is a little bit funky. We're doing some word problems. This is called linear programming. Linear programming, and I know that we're doing this when we see words like maximize and minimize. We're trying to maximize and minimize something, okay? We are going to use matrices, this is why it's in this unit, but we're also going to use graphs to kind of back up our work as well. Every so often I do a problem like yesterday, someone was like, oh, well, you could have known what the answer was by just reading the problem. Great, I still need to see all the work that you're going to use to justify that, okay? So let's read this problem. It says Johnson's Produce is purchasing fertilizer with 2 nutrients, nitrogen and phosphorus. They need at least 180 units of nitrogen and 90 units of phosphorus. Their supplier has 2 brands of fertilizer for them to buy. Brand A costs $10 a bag and has 4 units of nitrogen and 1 unit of phosphorus. Brand B costs $5 a bag and has 1 unit of each nutrient. Johnson's Produce can pay at most $800 for the fertilizer. How many bags of each brand should be purchased to minimize the cost? Okay, so the word minimize means that I'm going to want the smallest cost later on. We're gonna take all of these words and we're gonna go put it in this little chart to help us write equations to put in a matrix and to end up graphing, okay? So first thing, it says we need at least 180 units of nitrogen and 90 units of phosphorus. Where in this chart is 180 and 90 gonna go? Total, good. So I need total nitrogen is 180, total phosphorus is 90. Then it says brand A costs $10 a bag and has 4 units of nitrogen and 1 unit of phosphorus. Where do I put that? Good, and cost. So cost under column A is going to be 10. And how much nitrogen did they say was going to be in brand A? good. And then what about phosphorus? 1, good. So I'm filling in column A based on brand A. 1 gram of nitrogen, 1 gram of phosphorus, or 1 unit, whatever, cost is $10. Same thing for B. How much nitrogen's in B? Good. 1 of each. So 1 nitrogen, 1 phosphorus. What about the cost? $5. Okay. I know that they said the word 800. I'm not going to use 800 as any number. I'm actually not going to have a total for cost. We want to minimize it. So I don't want to set it equal to anything because I don't know what I want it to be. I want it to be as small as possible. Okay. Now, I've done this differently every year, but I think that I like what I'm about to do next. We're going to essentially take this box and we're going to just go immediately to our matrix. Okay. I have a nice little augmented matrix right here. I'm going to use that augmented matrix and I'm going to solve for X and Y. And X and Y in this case is my columns A and B. So it's going to tell me how much of brand A I should have, how much of brand B I should have based on this number, okay? This will not be my final number, but it's important to get this exact, and you can't always see it exact on the graph. Once it's in an augmented matrix, we're going to just do RREF. If they don't tell you how to solve it and you're trying to solve a matrix, I'm going to use RREF every time. So go ahead, enter in this 2x3 matrix, do your RREF, see what answers we get for how much of brand A and how much of brand B we should have. Based on this, how much of brand A should we get? 30. And how much of brand B should we have? 60. My handwriting looks so trash today. I'm not really sure what the deal is. 30 and 60. So that's a main answer we're going to find later, but there's going to be a couple other options that we're going to get based on our graph, okay? This might end up being our final answer. It might not be. You will see this answer on the graph in a minute. And so every year someone's like, well, why do we do the matrix? We end up doing the matrix in case it's not that pretty, in case it's hard to tell on the graph. You need to know exactly what my answer is, okay? All right. Let's go ahead. We're going to write some equations now, okay? So I've got some equations. And the first 2 equations we're going to write are going to come from that box. It's going to come from the matrix, okay? That first one, nitrogen, that in and of itself is an equation, okay? I can write that as 4x plus y. And I'm not going to say equals 180 because in the problem, it used the phrase at least. If I'm going to use the phrase at least, is that going to be greater than or less than? Greater than. I want this to be more than 180. It's okay if it's 180, but I really would like it to be more than 180. It cannot be 170. That's not going to be okay. So that's one equation. We'll graph that in a second. The other equation is just going to come from the second line. So what will that equation be? Good. Greater than or equal to 90. The next two equations you always have no matter what, and you can kind of tell based on this graph. We only care about positive numbers, so I want x is greater than or equal to 0, y is greater than or equal to 0. I help you out by always just giving you that quadrant 1, but we still need to recognize those are important equations. And then we'll have a cost equation, but we'll come up with that in a second. So leave a little bit of room for that, but I'm not ready to do that yet. Now it's our job to graph these, okay? It's pretty easy to graph x is greater than or equal to 0 here. It's pretty easy to graph y is greater than or equal to 0 here. What we'll need to do next is we need to manipulate my other two equations to get them to also be equal to 0 or equal to y, excuse me. So if I just take both of those and move the x's to the other side, I can just get y is greater than negative 4x plus 180. And then we'll graph that. And it's been a while since we graphed, but go up to 180, down 4, right 1. On this, I am going to go by tens. We did this yesterday, and I'm going to run out of a little bit of space, so I'm going to have to like pretend a couple marks up at the top, but I'm just going to go 10, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 40, 150. And I know we have to go to 180, but I'm just going to 160, 170, 180. It'll be fine. And then from here, I'll put my mark at 180 on the y, and then I'll go down 4, right 1. 1, 2, 3, 4, right 1. Remember with your slope, you can do that with any unit. You can still go down 4 over 1. You don't have to go down 4 individual ones. 1, 2, 4. But I'm going to end kind of at that like 1/2 mark there. I can also label my x-axis by tens as well. And so that's right about at 45, which should make sense for us. We're going to do the same thing for the next one. This one's just as easy. Move the x to the other side. Y is greater than or equal to negative x plus 90. I'll graph at 90, down 1 over 1, down 1 over 1, down 1 over 1. Now, both of these, I didn't shade when I graphed that blue one, but we need to shade. When it says greater than, we're going to go above the line. So I'm going to shade above the blue line. I'm also going to shade above that pink line as well. Because we want our answer to be in this like purple area where the blue and the pink are both touching. I know literally all of these points work as well, but I care about 3 specific points. I care about where blue and pink cross. I care about where I have a pink point and blue on one of the axes, and where I have a blue point in the pink on the other axis. So that means I care about 0, 180. I care about 30, 60, which we kind of knew that was going to be a point we cared about. And then we also care about 90, 0. All 3 of these points are potential correct answers, and cost is going to be what matters the most to us. Okay. I gave a little bit of space for an equation for cost, which we're going to use from our chart. We're going to plug those points in and decide which one is the best cost to answer. Because all of them give me what I want, but I want to know what's the best cost answer. Okay. When I write my equation for cost, I've got 10 and 5. What will my equation for cost be? Does anyone know? Think about how we did the other ones. Not yet. We don't want that yet. We're gonna plug those in.
The next one.
10x plus 5y. But then we'll plug in 30 for x and 60 for y, and 0 for x and 180 for y, and 90 for x and 0 for y, and see which ones work.
We're really good.
We want the smallest cost. We want to plug these numbers in, and we want to get the lowest number. First, we only have $800 to spend, so that means these are out. I also then only have one lowest price. My lowest price right here is the $600, which comes from my 30 and 60. So as annoying as it is that the first answer we found was correct, that's not always the case. So that's why we have to do all of them. But my answer is we need 30, what is it, bags? Units, oh, bags. 30 bags of brand A. Then we need 60 bags of brand. We're going to do one more of these just so that we have a little bit less tomorrow. We're going to actually skip number 2 and we're going to go to number 3. Go jump to number 3 whenever you're done with this one. I'll help you set it up and then I'll have you kind of try the matrix and the equations by yourself. Take a second and read the words. Notice that they did not give us a box. I, however, want one, so I'm going to draw one. Pretty bad box, but you'll be nice about it. If I'm not sure where to start, I'm going to start at the bottom, okay? Last time, cost was at the bottom of our chart. What's going to be at the bottom of our chart this time? What are we maximizing or minimizing? Profit. We want to profit. We want to maximize the profit. Okay, so I'm going to put profit at the bottom. And then let's see, what did they tell us we would get for profit? It says profit per acre of potatoes is 150, profit per acre of corn. Okay, so we're getting profit for each acre, and it depends on whether we're doing potatoes or if we're doing corn. That's how I know that those top 2 columns are going to be potatoes and corn. And I can put my 150 and my 50 in there when I'm ready to do that. The other 2, my side equations are going to be a little different. The first equation says he has a field of 70 acres in which he plants potatoes and corn. A number of acres is going to be my first equation. How many total acres does he have? 70. Did it tell us that we need more corn or more potatoes or there's any differentiation between them? No. We will have a certain number for potatoes, a certain number for corn, but we'll just put it in as one so that when I write my equation, it's like X plus Y. Certain amount of potatoes, certain amount of corn. What do you think my next equation is gonna be about? Cost, good. We'll go seed cost. How much is it for potatoes? 20, how much for 60? And then how much total does he have to spend on it? From here, I want you to take a minute, see if you can do your matrix first, then see if you can do your equations, and then I'll work alongside you momentarily. So far, I've done my matrix, I've done my RREF so that I kind of know what to expect. I'm expecting an answer of 30 and 40. I wrote my equations from my chart. And I solved both of them for Y so I can graph them. And I also set up my profits. Now I'm ready to go graph these numbers. Limit is less than, so we're going underneath that line. Find where the green and the orange overlap. Yep, either maximum profit, so highest, or lowest cost. Always about maximizing or minimizing. Now I'm gonna take those numbers I just found, plug them into my profit to see what solution, what idea is the best for us. So is it 0 things of potato and 50 things of corn? Is it 30 potato, 40 corn, or is it 70 potato, 0 corn? This one's kind of a different example where it's not the answer we got from the matrix. Right. I promise you're gonna have one like that on the test, not on the quiz tomorrow. I did not get a second to grade your guys' homeworks. I will get those done before tomorrow. So before the quiz, you want to look at it, make sure you don't do anything wrong that you did on the homework on the quiz. Okay. Your 7-4 is due tomorrow though, so make sure that you have that done. Again, I'll give you your 7-3 back tomorrow. I'm office hours if you need any help. Tomorrow should be a nice quiz, a nice way to come back from break.